Hello everyone, myself Ajit Prasad, student of Namchi Government College from BSc second semester. Today I am going to talk about Franck-hertz experiment. The Franck-hertz experiment was the first electrical measurement to clarify the quantum nature of atoms and thus transformed our undertaking of the world. It was presented on 24 April 1914 to the German Physical Society in a paper by James Franck and Gustav Hertz. Franck and Hertz has designed a vacuum tube for storing energetic electrons that flow through a thin vapor of mercury. They discovered that when an electron collides with a mercury atom, it could lose only a specific quantity, that is 4.9 electron volt of its kinetic energy. Before flying away, this energy losses corresponds to decelerating the electron from a speed of about 1.3 million meters per second to zero. A faster electron does not decelerate completely after a collision, but it loses precisely the same amount of its kinetic energy. Slower electron merely bounce off mercury atom without losing any significant speed or kinetic energy. Let us see how the experimental arrangements are done. Okay, this was the experimental setup for Franck-hertz experiment. They took a vacuum tube in which they filled with a mercury vapor. In that tube there are three electrodes: cathode, grid and anode, or collecting plate, and beside cathode there is filament which is connected with a low tension battery, and anode is connected with emitter and battery and connected with cathode. If the electron is moving from cathode to anode, the deflection shows in emitter, and we know, and thus this becomes a circuit complete. Emitter to show the deflection of electron, and there is a voltage V with a potentiometer. When the filament is heated, the electrons are ejected from cathode by the process of harmonic emission, and the grid is positively charged, so the ejected electron attract towards grid. If the electron crosses the grid and reaches to the point anode, then the circuit is completed and the deflection shows in emitter. Okay. When an electron ejected from cathode, and in tube there is mercury atom, in between them there is elastic collision, then there is no loss of energy and electron reaches to the anode. But in one point, electron and mercury atom has inelastic collision, which means loss of energy, and mercury atom, which is in ground state, will go into higher energy state, that is, they are unstable, and the which electron ejected from cathode, they are incapable of to cross the grid due to insufficient energy, and there is decrease in current. Okay, now let's see the graph, how the graph is being plotted. If we increase the potential to 4.9 volt, then the inelastic collision takes place and decrease in current. If we increase volt, current also increase, but at 4.9 volt it is suddenly decreased due to inelastic collision between electron and mercury atom. In graph we see the every interval after 4.9 volt the current decreases. If we add 4.9 to 9.4, 4.9 and 4.9 volt, it became 9.8. Again current decreases. Wavelength of light emitted a mercury vapor discharge by a Franck-hertz in operation to 10 volt. The Franck-hertz tube primarily emits light with a wavelength near 254 nanometer. The discharge emit light at many wavelengths based on the original 1914 emission spectrum from a Franck-hertz tube operated as a 2 voltage. The left-hand spectral line are obtained at voltage enough obtained and glow discharge of mercury atom in the tube. The single spectral line on the right is obtained at voltage above 4.9 volt. This is sufficient to excite the mercury atom but sufficient to cause a glow discharge. The drawing based on the original spectrum published on the Franck-hertz in 1914. The labels have been added. The original figure is unable to single 254 nanometer wavelength of Franck-hertz tube correspond well the 4.9 volt period of the electrical current through a tube. Franck himself described the figures in 1960 education film. Elastic and inelastic collision of electrons with mercury atoms. Electrons traveling slow change direction after elastic collision, but do not change their speed. Faster electron loses most of their speed in elastic collision. The lost kinetic energy is deposited into the mercury atom. The atom subsequently emits light and returns it to original state. Illustration of electron collision with mercury atom. In the Franck-hertz experiment, slowly traveling electrons undergo elastic collision which changes the electron direction of motion. Elastic collision do not affect the electron speed or the mercury atom. Electrons with higher speed lose most of their speed in elastic collision and deposited their lost energy within the atom. Shortly afterward, the atom emits light that carries away the deposited energy. In Franck-hertz experiment, the electron and between electron and mercury atom there is elastic collision. There is no change in speed. The speed do not affect if the collision is elastic. If the collision is inelastic, then the speed will decreases due to mercury goes at higher energy state, so the speed of electron decreases and the electron does not reach to the collecting plate, which is anode. Bohr's model of atom assumes that an electron could be bounded to an atomic nucleus only with one of a series of specific energies corresponding to quantum energy level. Earlier, classical model of binding of particle allow by binding energy. Illustration of Bohr's model assumption of quantum theory level of an electron. An electron can occupy any one of these levels with the corresponding energy binding to atomic nucleus. Intermediate binding energies are not permitted in Bohr's model. So the conclusion of Franck-hertz experiment was Basically, this experiment confirmed that existence of quantum theory. The energy state in an atom seems to be an abstract concept until the experiment was conducted. It confirmed the presence of energy state in an atom like mercury and neon. The quantum theory stated that those electrons in an atom exist in the discrete and quantized state. It was observed during the experiment that the current dropped suddenly at some specific value of voltage, indicating the changes in an energy of electron. The overall presentation of the phenomenon on CRO showed the several bumps in increasing and decreasing value of current. This was helpful to interpret the quantized level of energy. Hope you enjoy the video. Thank you.